This effort that I'm going to present is part of an international program for comprehensive stellar-sea research. With that, I'd like to put up my video. Tagging or branding and follow-up is one of the key ways to obtain data that is required to calculate population abundance and demographics. Until recently, these data have been collected by observers who had to go out to the rookeries and hullouts during summertime. Starting in 2010, we began installing archival cameras. Here are some pictures of them. The background is a sample image obtained with such camera. Currently, we've installed such cameras in major rookeries and hullouts in the Russian part of the habitat, as well as in the Aleutian Islands. These cameras have certain advantages. They operate morning to sunset. They stay in place for the whole year so that you get seasonal coverage. And these cameras operate for multiple years without any maintenance, meaning that people do not have to be out there in the field, which makes our operations safer. Yet there is one major drawback. The number of images obtained with such cameras is huge, and there is no knowledge in these pictures until you've processed them. Initially, we did the processing manually, but it became evident very soon that the inflow of data was much higher than our bandwidth. So we decided to automate it. And the obvious way to go about it was to use machine learning. We have two goals here. First, we need to identify branded animals in the picture, and then they need to be recognized. We used convolutional neural networks for that, or UNets. Or rather, UNet is one of the varieties of CNNs, and this one was used for identification of branded animals. The classifier, VGG16, allowed us to recognize the identified animals into different classes. Here is a schematic for a typical convolutional neural network. It has a number of layers that can be grouped based on the function. Here is a group of layers that does feature extraction. Any image fed into a CNN goes through a number of convolutions where the image is downsized and split into multiple channels. At each stage, with each convolution, unwanted features are filtered out. Human mind cannot comprehend this process, but the output is a flattened layer, which is then fed into a fully connected layer. That's a neural network which classifies these features and outputs a probability prediction of the class of that image. In our example, we trained this part of the model, and feature extraction layers were off the shelf. This expedited the training, and then it allowed us to use a smaller data set for training. There were three major stages. First, we were preparing images for training. Then we actually trained the model. And then we used the neural network to extract useful information from the images. The environment used was R, and we used different packages to expand its capabilities. Let me give you more detail about image preparation. All photos were segmented into smaller pictures that then were used to train neural networks. To train UNet, we used paired images, the one being a branded animal, and the other was a contrast mask to highlight the tag. Here are the results. That's the output of a trained neural network. And we see that it highlights the areas where it seems to think that there is the tag present. Usually it performs quite well. However, there are false positives as well. It identifies images where there is no brand or tag present or no animal even. Sometimes you can get as much as 70% of false positives. So we wanted to eliminate the errors, and we used classification models for that. The first stage used UNet output to identify the images with animals present and discard images there were no animals. The next processing stage was classification into not branded and branded. This additional refining stage gave us a new type of error, because you can throw out the baby with the bathwater, and some images with branded images were discarded as well, branded animals. So we had to evaluate the performance of each algorithm. The neural network is really good at identifying pictures with no animals and pictures with animals present. Here we had only isolated errors, very few of those. Then performance was also good for classifying tagged or branded and not branded animals. There is 15% of cases which cannot be easily classified. We did manual processing and decided that if you discarded this 15%, then the overall false negative rate would be about 7%. We continued to refine the model so that our false negatives are even lower. We supplemented the original training data set of 55,000 images with an additional 1,687 labeled or annotated images. This addition improved the predictive power of the neural networks, and our false negative rate went down to 1 to 5%. This range is due to differing performance of the model at different callouts. So how do we use that? It's not exactly zero touch, because you need some human input at certain stages. But it focuses human effort on specific animals and prepared pictures. And then it gives you a list of names to select from predicted choices. Then there is this human stage where we do error checking. If we identify errors, they can be fed back into the network to further improve its performance. So it's semi-automatic, but still, it shortened processing time significantly. Previously, it used to take up to half a year to go through one rollout. Now, it takes no more than 30 days, and which is a major step forward for us. With that, thank you, and I'll gladly take any questions if there are any. Thank you, Alexei. There is a question. Well, are there any raised hands? We have an additional minute before the next presentation. Yes, sir. There is a question by Dmitry Udovik. Let's put him online. Dmitry, please, the floor is yours. Thank you for the presentation, very interesting. What environment was used to label the images? And do you think this size of a data set would be sufficient to not just identify animals in the pictures, but to identify and recognize the brand tag as well? Okay, thank you for that question. We did labeling in our own software that we developed that allowed us to highlight the areas that were of interest. As for brand recognition, the data set needs to be much larger. And the larger the data set, the higher the probability that the identification is going to be correct. We need at least 100 images for a given name within a certain class. That would be different angles on the same animal with one and the same tag brand. If you have just 2 pictures, then that's not just going